Hello friends, hope you are having a fantastic day today. So in this video, we are not only going to solve a very popular LeetCode problem, we are also going to learn a brand new Dutch national flag algorithm. And this algorithm has actually been developed by Dijksters, our very own god of shortest path algorithm. So without any delay, let's get started. So the name of the problem is called sort colors, and you can see that this is a very popular LeetCode medium problem, and this problem has been asked in bunch of companies like Amazon, Google, Microsoft, all of them. So let's try to understand the problem statement. Basically, we are given an array nums with n objects, and each of the object has been marked as one separate color, red, white or blue, and we need to sort these in place, which means in big O of one space complexity, in such a manner that the same colors are adjacent to each other, and the order of the color has to be red, then white and then blue. Now we are being told that because we are given an integer array, each integer is represented by a color, and this is actually the flag of Dutch nation Netherlands. Now let's try to understand this with some of the real life examples. So suppose we are given an integer array like this. Now we need to sort this array in such a manner that each number is next to each other, like its color type, and also we need to follow the sequence of 0, 1, 2 or red, white and blue color sequence. Okay, so first is going to be 0 because we only have 1 0, then we have 2 1s, so in the answer we are going to mark 2 1s and then 2 2s. So this is going to be the solution that we need to return. Now you must be thinking that, hey, this is a very simple problem. Why is this even a LeetCode problem? Because in this given array, if you just apply like sort function or a sort library that every single language has, like Java, Python, you name it, then it can generate this answer pretty easily in like big O of n log n time, and you don't have to do anything. But there are a couple of caveats to that. Number one, we are being told that we must solve this problem without using the library sort function. So that is number one. Number two is that the library sort function actually solves this problem in big O of n log n time. But I'm going to show you how to solve this problem in actually even faster in big O of n time using the Dutch national flag algorithm. Now first, if we want to see the brute force approach, or if we want to see like some more inefficient methods, there are all there. Like in the brute force, you just iterate one by one and find each values and then start sorting them. So brute force is going to yield in big O of n square time complexity. The better or more efficient approach is using the sorting function or merge sort or quick sort, that is going to yield big O of n log n time complexity. But now let's just see that what is going to be the optimal solution for this problem. So what we are going to do is, instead of taking advantage of any of the existing library functions, we are going to take the advantage of the fact that we only need to sort 3 distinct items, which means in either cases, the number of possibilities that, let's say that if this is the first section and this is the second section, the third section has to be only this much amount, right? There is going to be a very clear distinct boundary. It can be anything. It can be like the first value is only just one value, the second value is only these 4 values, then also all the middle portion or all the remaining values are going to be value number 1. So we are going to take advantage of this fact. In order to achieve this fact, what are the information we need? Well, number one information we need is that where does 0 end? So because currently we are trying to sort 0, 1 and 2, 3 values, right? So we will know that where does 0 end. We will also know that where does 2 start, and all the portion in between has to be 1. And using this fact, we should be able to solve this problem in big O of n time. So let's try to see the example of what I'm suggesting, and then it would make things much more clear. So let me just clean this up a bit. Let's assume that currently we are given this array, and let's add some random values, right? So let's add values like 1, 2, 0, 0, 1 and 1. Okay, suppose these are the values we are currently given. Let me just add a couple of more values to make it more like longer, and let's just add like 2, 1 and 2. Okay, suppose these are the values currently we are given. Now what I'm suggesting is that we leverage 3 pointers. So first pointer is going to be called left pointer, this pointer is going to keep track that where does the initial zeros needs to be placed, or where do they, so if we encounter 0 at any moment, this is the position where the 0 has to be entered in the existing array. Next, we are going to keep track of the right pointer or a high pointer. So this is a low pointer. Now let's just mark this as high pointer. So next we have an h pointer, and this h pointer is going to take the index position where if we at any given time encounter value number 2, it has to go on that place. And then third, we are going to have a current pointer. So this current pointer is going to help us iterate over the given existing array. Now this is the logic. Now let's try to understand what I mean. So initial position would be that currently left pointer is located at the very first position, because imagine at any given moment we encounter a 0, that 0 has to be at the very first index location. So this value has to be 0 if there exists 0. If there does not exist 0, then that's fine. Same way, if there exists a 2, at least the 2 has to be here, or if it is not here, then there should not be any 2 in the entire array in the sorted position. So for the h, we are going to place at the end, and since for the current array we are just taking its help to iterate over, we are going to have initial position for current array at the very first location. Now the logic is we will first check, okay, whether this value is 0 or 2. Okay, if currently this value is neither 0 nor 2. So we are simply going to move our current pointer one step forward. Moving current pointer one step forward, now currently this value is 2. Now because this value is 2, we will have to update into, or we will have to swap values with current h pointer. Okay, so I think this, let's just make this value something else. Let's just make this value 0. So because I didn't want it to have h value at pointer number 2. Okay, and now let's just, so we realize that this value is 2. Because this value is 2, we will have to swap it with the position of h. So current position of h is 0. So we are simply going to do a swap operation. So let's just swap these two values. Currently this value is 0 and this value is 2. And now once again we will, because we know that this is the position where we already have a 2, which means next time if we encounter 2, 2 has to be placed one step before that. So we are going to update the value of our h pointer, and we are going to keep on repeating the same process. Now notice that we haven't updated the c position at this moment, because we did not know what value could be coming from this h side, and if the value was 0, we would have to iterate it over. So because in this case this was the same case, because this value was 0, so now we realize that current is located at the 0th position. So if we encounter 0 position, we will have to place it where current L stands and then update the value of L in the same manner. So now we are going to swap these two values. This value is 0, this value is 1. Now we know that this first value is guaranteed 0. So we are going to update the value of our lower pointer. And when we do that, we are going to have encounter L over here. And now since we already processed this node, we can move forward to the next node, because we already know with C that this value was not 0. So the only position was that this could have been 1 or 2. If it is 1, then we just move forward. If it is 2, then we would have replaced it with the last value. Okay, so now let's just once again go to this position, and currently this is our C. Repeating the same process, we've identified that this value is 0. So now we will have to swap it with the current L value. So we are going to replace like that, and we are going to update the position of L, and we are also going to update the position of C. So now we have our C located at this 0th position. Once again, we are going to repeat the same process, and we are going to swap operations. So 0 and 1. Now L comes over here and C comes over here. So let's just update these. Okay, now this value is 1. So we don't care, we just move to the next value. This value is 1. Once again, we don't care, we just move on to the next value. And now our C is currently located at this position. So now this value is 2. Because we find a value that to be 2, we will have to replace it with the value of h. So we are going to do that replacement, and we are going to have our h value be located over here. And we still have our C value over here, because what if this value could have been 0, though it's not, but if it was 0, we would still have to process it. And once again, we are going to, in the next iteration see, okay, so this value is 1. Because this value is 1, now we are going to move to the next value. And the moment we identify that either the given current location and the location of h is equal to each other, then we can end the loop. Or we've identified that this L and H are like equal to each other, then also we can end the loop. And now if you see the final answer, you can see that this array is completely sorted. So first 3 values are 0, next 4 values are 1, and next 2 values are simply 2. And this is the sorted answer that we need to return. Now you see that how beautiful this solution looks. And if we see time and space complexity, in order to solve this problem in terms of time complexity, we are simply solving in big of n time, which is excellent. And in terms of space complexity, apart from storing few pointers, we are not using any extra space. So we are also solving this problem in big of 1 space complexity. This is so great because typically whenever we see sorting, we always solve sorting using n log n time. But for distinctively purpose of sorting just 3 distinct variables, we are being gifted this by Dijkstra, this Dutch national flag algorithm. And this is how we can solve this one. Now let's try to implement this using the code. Okay, so here is the solution for our code. So first we are initializing 3 pointers. First pointer is low pointer, next pointer is high pointer, that is located at the very last of the given array. And then we have the current pointer that we are going to use to iterate over all the values. Now we have the condition that while current is less than or equal to high, we are going to keep on repeating the same process. First we are checking that if the given current position, the value element is 0. If the current value is 0, then we will have to swap it with whatever the location of this low pointer is. So we are going to have a helper method swap that is simply going to allow us to swap 2 values. So we are going to swap the current value with the position of low. Then we are going to increment low, and we are also going to increment current. If that is not the case, and for some given moment, if the current value is equal to 2, then we are going to swap number of current with the high value at the very end, and we are only going to reduce the value of high. We are not going to increase the value of current because that number could be 0. So we will have to repeat and redo the same operation. And last, if both of these are not case, which means this given current value is value number 1, so we can simply update the value of the current pointer, and this is the whole solution. Now let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs 100% faster than all the other solutions, which is pretty awesome. And in terms of memory usage, we are also much more efficient compared to a lot of other problems. So once again, I would be posting this solution in our GitHub repository, so you can check it out from there. Thank you.